Hello learners, I welcome you all. I am Mohini Arora and I am here to present before you a session on arrays which is a part of computer science course of NIOS. So let us begin with the course. In this session, we will be covering what is an array, we will be explaining the concept of an array, we will be defining, accessing and initializing the array elements. We learn how to perform common operations on one-dimensional arrays and explain two-dimensional arrays as well. We will also define and initialize two-dimensional array elements in this particular session. So, I hope you learn and you enjoy this session. First and foremost, let us begin with what is an array. An array is a set of values of similar data type. Say for example, you want to store marks of 10 students. Till now, whatever programming portion you have learnt, you will have to create 10 variables to store 10 numbers. So, instead of storing 10 variables, maintaining 10 variables, entering data into 10 variables, we create an array where each data is of same data type. And we can specify the size of the array, we can specify the number of elements that an array should contain. So, that is why in the example you can see that I have given a set of marks of 10 students can be formed into an array, like a name is a set of characters, so that can be an array. And you should always remember that when a memory is allocated to an array, it is in contiguous manner, means it is stored in consecutive address locations. So, that is how an array is formed when we declare an array. So, now coming to the portion of how to declare an array. So, the screen shows you the syntax to declare an array. Since I mentioned before that an array is a set of elements of similar data type. So, obviously, data type has to be mentioned while declaring the array. So, the syntax goes as we give the data type, we specify the data type, it can be of any data type, an integer, character, float, double, long int, any of the data types that you have learned before. So, we specify the data type, then we specify the name of the array and then we specify the size of the array. Here size of the array means the number of elements that I want my array to contain. Say in the previous example as I was mentioning that I want to store marks for 10 students. So, the size of the array will be 10. Why? Because I want to store 10 numbers. An array can be a one-dimensional array which contains one subscript. Data is stored in linear fashion. You can say either in rows or in columns. So, let us talk about declaration of an array, how to declare an array, how to tell the compiler that yes, I want to create an array. So, the syntax on this slide that you see, it talks about the data type first. As I told you before, I mentioned before that an array is a set of elements of similar data type. So, the word data type holds utmost importance here. According to the data type only, memory is allocated to the array. So, first and foremost, while declaring an array, I specify the data type, then I give the name of the array. The name of the array can be any name according to the variable name conventions that you have done in the previous chapters, and finally, we specify the size of the array. When I talk about the size of the array, I talk about the number of elements that I want my array to contain. Say for example, in the previous slide I was talking about that I want to store marks of 10 students. That means I want to store 10 data elements. So, size of the array in that case will be 10. An array can be of one-dimensional type or a two-dimensional type. A one-dimensional array has one subscript, data is stored in linear fashion, while a two-dimensional array has two subscripts. Data is stored in rows and columns in the form of a matrix. So, the example that you see here, the first example talks about int price. The data type is int, the name of the array is price and the number of elements that are contained in this array is 5. So, that means size of the array is 5. Since this is having only one single subscript, here subscript is in square brackets the number 5 is the subscript. So, since this particular example is having only one subscript, it is the one dimensional array. The second example where we talk about int set of names. So, the variable name is set underscore names and the size of the array is 5 and 20. So, here 5, the first subscript is 5 which specifies the number of rows, and the second subscript is 20 which specifies the number of columns. So, since this particular array, that is set underscore names, has got two subscripts, so this is known as a two-dimensional array. In this particular session, we will be covering both one-dimensional and two-dimensional arrays. Let us first talk about the one-dimensional arrays, but before that, based on the data that I store on the array, we have two types of arrays, number arrays and character arrays. Number arrays contain numeric data, integers, floats or double. This particular data can have arithmetic calculations on it. On the other hand, character arrays contain characters, and a character array is also referred to as a string. So, we will be covering both number arrays and character arrays along with one-dimensional arrays and two-dimensional arrays in this particular session. So, we learnt how to declare an array. Now, we talk about initialization of one-dimensional array. Initialization means giving initial value during the declaration of an array. As variables that we had done before created with fundamental data types can be initialized, similarly an array can also be initialized during declaration. The screen shows you the example also where there is an integer array of size 5 which is initialized with values 1, 2, 3, 4, 5. You can see that all values are separated by commas and the entire set is enclosed in curly brackets. So, whenever the array is declared along with the size, if the array is declared of size 5, so 5 values are given at the time of declaration itself. Another method to initialize is also given where I am not specifying the size. In the second example that you see, an array B is created, but the size is not specified. This is also a valid syntax. Here the compiler automatically takes the size by counting the number of elements during declaration. So, in this example I have 5 elements, that is 6, 7, 8, 11 and 10. So, array B is given the size 5. So, that means the memory is allocated according to the 5 elements that are being initialized with in this particular array. So, these are the two ways in which arrays can be initialized. Now, we move on to strings. We just talked about initialization of number arrays. Now, we talk about initialization of a string. A string can also be initialized, that means it can be given values during declaration itself. Since a string is a set of characters and every constant character is enclosed in quotes, so here also the value with which the string is being initialized is enclosed in double quotes. The word computer science that you see on this slide is enclosed in double quotes and the size of the array A is 20. Second example, as we did in number arrays, here also I am not specifying the size of the array, but I am initializing it during declaration. So, in this example, the size of the array is taken automatically by the compiler by counting the number of elements that are present in the array. Here I would like to mention one more thing, that every string or every character array is terminated by a null character always. So, whenever you declare a string, you should always keep 1 byte extra for the null character. That means if I count the number of characters in the array B, I have 1, 2, 3, 4, 5, 6, 7, 8 characters in Calcutta and 1 of null. So, B will be allocated 9 bytes of memory. That is another difference between a string, that means a character array, and a number array, that a character array is terminated by a null character, but a number array does not contain any null character. See, this is what I was talking to you about. This is the null character in a string. You can see that here I am specifying each and every element separately in single quotes. That is why the character null at the end also has to be specified separately in single quotes. In the previous declaration, since the entire word Calcutta was given together in double quotes, so null need not be specified. But nevertheless, this method or the previous method, a string is always terminated by a null character. A number array on the other hand does not contain any null character. So, with this we move on to, now we have declared an array, we have initialized an array. Let us now process the elements of the array, let us now work with the elements of the array. The various operations possible on arrays are traversal, searching, sorting, insertion of an element in an array and deletion of an element in an array. So, let us cover all these one by one. First, we talk about traversal of an array. An array is traversed means I am moving in an array from one location to another, from one element to another. Usually, I begin traversal from the beginning. That means from the first element of the array. So, if an array has 5 elements, I start traversing from the first element, then I move on to the next element, then I move on to the next element and so on till the time the last element is reached. I can traverse an array for various purposes, but generally it is used for display purposes. I want to display all the elements of an array, so that means I want to traverse an array. So, for traversal, see, there is a code here where there is a program that is accepting values from the user and finding out the maximum value entered. Means a user is being asked to enter a set of values and your program's output is which value was the maximum one out of the 5 entered. In this example, you will see that an array is created of size 5. The name of the array in the example is A. First for loop accepts the elements of the array, that is why the cin statement is inside the loop. Then I move on to the first element of the array. A0 is the first element of the array. I store that element in variable t and then I start my loop again. I start traversing from the beginning again. This loop will terminate when the value of I has reached 5, that means 0, 1, 2, 3, 4. The 5 elements have been checked upon. What am I doing in this particular loop? I am checking whether the value of t is less than the element, means suppose the value of t was 2. First element of the array was 2 and the second element of the array is 4. So, 2 is less than 4. In that case, t contains 4, it does not contain 2. So, the variable which is storing the maximum value, in this example it is t, it gets a new value every time an element with larger value is encountered. So, at the end of the loop, I have the maximum value that is displayed in the form of t. So, in this particular example, I am traversing, I am moving from one element to another. If you see inside the second for loop, I am moving from one element to another, from I equals to 0 to I equals to 1 to 2 to 3 to 4 and so on. So, I am moving from one element to another and this process is traversal. So, traversing of an array you will do very often during the programming course, because every time when array elements are accepted, you need to move, you need to check them due to some or the other logic. So, traversal is of utmost importance for arrays. Next, we move on to searching. Searching is finding a particular data element in an array. I have accepted certain elements, say 5 or 6 or 7 elements in an array using the loop. I want to search whether a value exists in an array or not. Say I entered an array with the value 4, 5, 7, 8, 9, 10 and I want to search whether 5 is existing in the array or not. The message should come accordingly. So, this particular technique where I am searching for an element is the searching technique. There are two types of searching methods that are covered in your course. First is the linear or sequential search and the second is the binary search. In case of linear search, I am checking each and every element one by one, means I am traversing and I am checking the element. So, first element I pick up, I compare with the data element to be searched. If it is found, I give the message that the element has been found and I close my program. If it is not found, then I move on to the next element, means array is traversed from beginning till end. Since this method requires lot of comparisons, say for example, the element that I want to search is at the end of the array. So, that means I am doing so many comparisons before I am reaching the actual element. That is why this method of linear search is considered to be slower, inefficient and it works on unsorted lists, means there is no proper order in which the array is being stored. So, this is what is linear search. Then see, this is the example that is coming on your screen of linear search. Here the array is created of size 5, then the user is asked to enter those 5 values. The first loop is accepting data values, then the program asks about the data to be searched. The variable that is storing that particular element is data. Inside the second for loop, I compare. See the if statement, it says if ai equals to data, means the element that is being traversed, that is being checked. First I will be 0, the first element will be checked. Next time I will be 1, second element will be checked, then third element will be checked and so on. So, with every element I am comparing with the value of data. If it is found, the value of flag, another variable whose value was initialized to 0, now it changes to 1. So, at the end of this particular loop, if the element is found, means some comparison returns to be true, the if statement that is inside the for loop comes out to be true, then flag becomes 1, and if flag becomes 1, then obviously the data is present. So, this program that you see on your screen, this shows the linear search mechanism where I am traversing from the first element till the last element, and at every step I am comparing the value to be searched with the array element. If it is found, the variable changes and we display that the data is present, otherwise data is not present. If the array completes, 5 elements were there in the array and 5 elements are checked. So, the array is complete and I have not found any element, the flag still remains 0, then the data is not present. So, this is linear search, a simple method, but it is very slow and very time consuming method. It takes lot of time of the processor. So, a better technique that we have is binary search. Very useful, very efficient technique which brings down the comparisons to half. That is why it is a very fast method of finding an element in the array. But to do binary search, the array has to be sorted either in ascending or descending order. According to the binary search logic, it calculates the middle location of the array from the initial and final locations. That means, say the size of the array is, say suppose 9. So, the first subscript will be 0 and the last subscript will be 8. So, the middle element, the subscript will be 4. So, I find out first the middle location of the array and then I compare the element, the data that I wanted to search with the middle location. As you can see in the next slide also, there can be 3 situations. I found out the middle location, see the subscript was 4. There can be 3 situations, either the number that I want to search is less than the middle value, middle location value, it can be greater than the middle location value, or it can be equal to the middle location value. So, if it is less than the middle location value, so the data to be searched is present in the first half of the array. Say for example, I see the next slide, it shows in diagrammatic form very clearly. In this particular example, you can see that the size of the array is 9. The lower subscript, the variable name I have given is initial, is 0. The upper subscript, the variable name is final, is 8. So, I find the middle location. 0 plus 8 divided by 2, that means 4. The middle location is 4, the middle subscript is 4, but the value at the middle subscript is 23. So, that is why it says ARR mid is 23. So, now suppose the data that I want to search is 12. So, 12 is less than 23. So, the element to be searched now will be searched only in the first half of the array. I need not do any comparisons in the second half of the array, because the list is sorted. I know that in no circumstances, since 12 is less than 23, it will be found in the second half of the array. So, a lot of processor's time is saved when data is searched using the binary search technique. If the data to be searched was to be 23, then obviously it is the middle element, the element is found at this particular location and you exit out of the program. So, you see that using the binary search algorithm, binary search technique, the number of comparisons are proportionately reduced. That is why it is a very efficient and faster method of searching a particular element in an array. The next slide shows you the program of binary search, where I am having an integer array ARR. I declare variables initial, final, mid and data. I first accept the array elements and then I accept the data to be searched. It is stored in the variable num. The initial subscript is 0 and the final subscript is size of the array minus 1. That means, if the array length is 9, then the final subscript will be 8 because it starts from 0. So, using those two values, initial and final, I calculate the middle element, the middle location. Once the middle location is found, it is stored in the variable mid in the program. Then I start checking out what is the value of the middle element with respect to the data to be searched. And this process will continue till the time either the element is found or the initial and final come together. That means, till the time initial is less than final, the lower subscript is less than the higher subscript, the upper subscript, till that particular time this loop will continue. And I am just comparing it and I am giving the new values to initial and final. So, every time the loop iterates, every time the loop runs again, a new final or a new initial value is obtained, a new mid value is obtained and comparisons are done. So, in this particular program also, I compare if the middle value is equal to num, then data is present. If the middle value does not compare to num and initial becomes greater than final, because every time initial is being incremented by 1 with every loop and final is decremented by 1 with every loop. So, if initial becomes greater than final, then data is not present in the list. So, that is how the binary search algorithm works. Very efficient, reduces the processing time because it reduces the number of comparisons. So, these are the two searching techniques that are there in your course. Next, we move on to sorting. Sorting is a method to arrange the list in either ascending or descending order. Two types of sorting are covered in your course, bubble sort, where two adjacent elements of the array are compared and then they are swapped if required, and selection sort, where the smallest or largest element is first found out from the array and then it is swapped with the proper position where it should be. So, these two sorting techniques have been covered in your curriculum. Next, we move on to the insertion of an element in an array. Insertion is adding of the data item either in the middle or in the beginning or at the end of the array. For this, we first find out the position where the element should be inserted. You can use any of the search procedures, you can use either linear search or binary search for this particular task, and then you insert data into that particular element. Similarly, for deletion also, we first find the location of the element to be deleted and then whatever value has to be deleted is overwritten by the next element of the array. So, that is how the elements of the array are deleted from there. So, this is how we have worked with one dimensional array. Now, we talk about 2D arrays or two dimensional arrays which has two subscript as I had explained below before also. The first subscript is for the rows and the second subscript is for the column. In this example also, I have declared an integer array of size 5 and 4, where 5 is the number of rows and 4 is the number of columns. Another example of 2D array where the subscript location is shown. You can see that rows are horizontal and columns are vertical. So, first element is having the subscript 0 0. In the same row, second element is having the subscript 0 1. Why? Because the row is same, the column has incremented. Similarly, 0 2, the row is same, column has incremented. So, this is how the subscripts move in an array. You have to keep track of these subscripts. You should understand how the subscripts are made so that you can work on the arrays and create your program. So, as we initialized one dimensional array, exactly in the same manner we can initialize a two dimensional array also in curly brackets and each element separated by a comma. You can initialize row wise or you can initialize giving all the elements together also. So, this brings us to the end of this session. So, by this time you have understood what an array is, how to define, access and initialize array elements, how to perform common operations like traversal, like sorting, like searching in an array, inserting an element, deleting an element also we covered. We also touched upon two dimensional arrays, their declaration, definition and initialization. So, with this we come to the end of the session. I hope this session was a good learning experience for you and you gained from it. Thank you.